In this lesson, we will learn how to tackle questions involving simple interest and compound interest. Let's begin with a simple interest question. Now in this question, we are told that Nico deposits $500 in the bank with a simple annual interest rate of 8%, and we want to calculate how much money he has after 3.5 years. Now a simple interest rate of 8% means that each year Nico will earn 8% on his initial $500 deposit. So to begin, let's determine Nico's annual interest. This will be equal to 8% of $500, which is the same as 0.08 times 500, which is 40. So Nico will earn $40 interest each year. Alright, now let's use this table to keep track of the interest that accumulates on Nico's $500 deposit. So after 1 year, $40 will have accumulated. After 2 years, another $40, bringing the total to $80. After 3 years, we add another $40 to bring the total to $120. Now to find the interest after 3.5 years, we need to add half a year's worth of interest. In other words, we will add $20 to bring the total to $140. Now another way to calculate simple interest is to use this formula. It says that if some investment collects simple interest, the interest that accumulates will equal the principal, that is the amount of money initially invested or deposited, times the annual interest rate, times the number of years the money collects interest. So for this example, the interest on Nico's money will equal the principal of $500 times the interest rate of 8%, which we can express as the decimal 0.08, times the number of years, which is 3.5. This product is equal to $140, which is the same as the amount of interest we calculated using our table. So if Nico's money collected $140 in interest, then Nico now has his initial investment of $500 plus $140 in interest for a total of $640. So that's pretty much how we handle all simple interest questions. Now let's examine questions involving compound interest. Now compound interest is much different from simple interest. With compound interest, any interest that accumulates is added to the initial investment, and the new balance is then used for future interest calculations. Now the formula for compound interest is much more complex than the formula for simple interest. Also notice that the simple interest formula only helps us calculate the interest that accumulates on an investment, whereas the compound interest formula helps us calculate the total value of an investment, not just the interest. Okay, now let's examine the different variables involved in this formula. First, P is the principal, that is the initial investment. R is the annual interest rate expressed as a decimal. C is the number of times the interest is compounded each year, and N is equal to the number of years the investment collects interest. So for this question, the principal P is $500, the annual interest rate is 0.08, the number of compoundings, C, each year is 4, since the question tells us the interest is compounded quarterly, and finally N, the number of years, is equal to 5. At this point, we can take our formula and plug in the corresponding values. Now when we evaluate this fraction, we get 0.02, and when we evaluate 5 times 4, we get 20. Finally, when we simplify 1 plus 0.02, we see that after 5 years, the dollar value of Amy's investment is equal to 500 times 1.02 to the power of 20. Now, as you can imagine, we would never need to evaluate this expression, since the answer choices would be given in a similar format. Alright, now let's try another compound interest question. Here, Zach invests $40,000 at an annual interest rate of 12%, which is compounded monthly. Our goal is to calculate the value of Zach's investment after 2 months. So once again, we will apply the compound interest formula. Now for this question, the principal is $40,000, the annual interest rate is 12%, which we will write as 0.12, and the investment is compounded 12 times each year. Now when it comes to the length of time the money is invested, remember that we must enter this value in terms of years. So if the money were invested for 1 month, the number of years would be 1/12. So 2 months will be equal to 2/12 years. Okay, we can now calculate the value of Zach's investment by plugging in the corresponding values. Now when we evaluate this fraction, we get 0.01, and when we evaluate 2/12 times 12, we get 2. This simplifies as follows. Now on the GRE, if we have a compound interest question where the total number of compoundings is relatively small, we may be required to evaluate the actual value of the investment. So here, if we evaluate this, we get a final value of $40,804. Now in situations where the number of compoundings is relatively small, and we are required to find the actual value of the investment, it is probably faster to skip the formula altogether and perform the calculations each time the interest is compounded. Here's what I mean. First, since we have an annual interest rate of 12%, and since the interest is calculated 12 times in 1 year, we can say that the interest rate each month is 1%. Okay, now let's take Zach's $40,000 investment and calculate the interest after 1 month. Well, if the monthly interest rate is 1%, then the interest will be 1% of $40,000, which is $400. So after 1 month, Zach's investment is worth a total of $40,400 since the interest is added to the initial investment after every compounding. At this point, we can determine the interest after another month elapses. This will equal 1% of $40,400, which is $404. When we add this to the previous balance, we see that after 2 months, Zach's investment is worth $40,804. Alright, let's summarize. In this lesson, we learned how to calculate compound and simple interest, and we learned that for compound interest questions with few compoundings, it may be faster to perform incremental calculations as we did in the last example.